Energy Revolutions, where we'll be covering one of the big issues facing the world today, sustainable energy. Where people may talk about an apocalyptic energy crisis, we mean to show that sustainability is a unique, creative challenge that society can rise to. I'm going in search of 3 distinct energy sources: fossil fuels, renewables and nuclear. We'll be giving a balanced picture of what using these sources would mean, while busting some myths on the way. Today, our focus is on fossil fuels, natural gas, oil and coal. I'm heading down to one of Sheffield's old industrial quarters to look at the way fossil fuels were crucial to the development of the modern world. I'm here at the Kelham Island Industrial Museum, where the sheer power of fossil fuels is especially evident in the enormous River engine.
Engines like this formed the backbone of the Industrial Revolution, fueling a huge economic and technological boom in Sheffield and the UK. The latter half of the 19th century oversaw a vast improvement in standard of living for people from all walks of life. Transport and electricity plants also came to rely on fossil fuels, making much of our modern lifestyles possible. Much of the improvements in life expectancy, food, and global connectivity made over the last 200 years would not have been possible without them.
But does all of this mean that fossil fuels are still necessary today, in 2014, to maintain our industrialised world?
Even today, about 80% of the world's energy consumption comes from fossil fuels. You could conclude from this that if we wanted to kick our dependence on fossil fuels, it would not be easy. However, in the long term, we may have to, because these fuels are ultimately limited.
This is something I put together. I don't know how useful it is, but trying to answer the question, how many years of a world's energy supply are there in different fuel-based systems? And on each of these, there's 3 bars. It's logarithmic. One is the lower resource, so how much oil do we actually know there is around. One's the upper resource, how much if you extrapolate to the whole world, unexplored regions. And then what about unconventional oils? Roughly, oil could only supply 10 years of our present energy demand, or maybe 20 years if we explore more regions, and possibly up to 100 years with unconventional oils. Same with gas, except that there's this speculation that there's massive amounts of methane trapped on the seabeds that we may or may not be able to access, and we may or may not be able to access without releasing uncontrolled methane releases into the atmosphere, which would be very bad. Again, coal, so we're getting up to 100 years, not too bad.
While improved efficiency has reduced the amount of energy we need for certain tasks, demand is continuing to rise around the world. It may be that with enough coal, we can meet this demand for a few generations. Coal, however, is the worst offender for releasing carbon dioxide, which comes with its own problem: human-caused or anthropogenic climate change.
Now, climate change is a fact of life for the Earth. The temperature has varied wildly over the lifetime of the planet. Some life forms adapt to these changes through evolution and form new species. Their contemporaries that don't adapt simply die out. But what's different about present-day climate change is just how rapid it is. The latest report from the IPCC emphasises that today climate change is happening extremely fast. Warming of the climate system is unequivocal, and since the 1950s, many of the observed changes are unprecedented over decades to millennia.
Unfortunately, the IPCC is equally unambiguous about the cause of the warming. There's no question that human emissions of greenhouse gases, especially carbon dioxide, is the reason behind it.
Some species have already gone extinct from climate change, with more to follow. Researchers in the field even suggest that a planet-wide extinction event will occur unless action is taken. The Industrial Revolution may have produced an economic boom, but now the continued use of fossil fuels has the potential to cost the world dearly. In fact, the Stern report of 2007 estimates that around 20% getting our energy from different sources and by using existing sources more sustainably. In fact, the Stern report goes on to mention that only 1% of the world's GDP needs to be used in order to avert this damage.
One possibility is fitting existing fossil-fired power stations with carbon capture and storage, or CCS technology. But CCS also comes with an energy penalty. It could take up as much as 25% of the energy output from a coal-fired power station. When making a move from the status quo, there are also the monetary costs to consider.
Okay, so the way that I think energy generation and demand is often contextualised is certainly in the context of carbon and carbon abatement, is in terms of something called the marginal abatement cost curve, MAC. On the x-axis here, we have the cost. No, we don't. We have the abated carbon. So we have basically the amount of carbon that has been saved by a particular intervention. And the y-axis here, we have the kind of cost of that saving. And some things make perfect sense to do straight away, right? So changing incandescent light bulbs to LED lighting basically comes out negative on the MAC curve. There's a definite saving, both financial terms and in terms of the carbon that's been displaced. You get the same amount of light and you don't need to spend as much on your electricity bill. So LED light bulbs are perfect, right? And then on the other end of the MAC curve, there's things that really don't make sense to do now, but if you want to save a certain amount of carbon, then someone's going to have to invest. A great example of that is carbon capture and sequestration. It costs a huge amount to do this. There's no immediate financial benefit, but to get a certain amount of carbon saving stacked up, we've got to have to invest in that sort of thing. And in the middle are things like solar PV. It costs a little bit, and you get carbon back.
Fossil fuels are cheap at the moment, but it may be in order to tackle carbon emissions, CCS will become standard. This would raise the cost of burning fossil fuels, making alternative energy sources more competitive.
This suggests that even with CCS, the continued use of fossil fuels can only ever be a temporary measure.
In the next episode, we'll cover some of the alternatives to fossil fuels, with a look at renewable energy. Clean, plentiful, and popular with environmentalists. Does renewable energy really have what it takes to meet our energy needs? It's all in the next episode of Energy Revolutions.
I only knew you for a while. I never saw your smile till it was time to go.
If you'd like to learn more about the scientific basis for climate change, you can download the IPCC Summary from the link in the description. And for more details, the full report from 2013 is also linked below.